Okay, starting with numerical number 1.8, a spherical water balloon is revolving at 60 revolutions per minute. So here we have frequency, that is 60 revolution per minute. We can convert it into second by just dividing by 60, because 1 minute is equal to 60 seconds. So this is now converted into seconds, that is 60 upon 60 revolutions per second, which is 1 revolution per second. Now after that, suppose this is that balloon revolving at 60 revolutions per minute. In the course, let the mass of this balloon be m1, mass of initial balloon. In the course of time, means after some time, 48.8% of its water leaks out. 48.8% of your initial balloon leaks out. Means suppose this much part of the water leaks out. So now you have new balloon of this size. So let the mass of new balloon be m2. So can we calculate m2? Yes, of course we can calculate m2, because this portion is given to us, that is 48.8% of water has leaked out from the balloon. So let me first show you the calculation. See, suppose you buy something of 100 rupees and from that you have 30% discount. So how will you calculate this 30%? That is 100, whatever is the initial value, into 30%. Right, that is 100 into 30 upon 100. So 100 get cancelled, means you will subtract 30 from your original one. So 100 minus 30 will give you 70 rupees, right? So my main motive is to show you that when you calculate this percent, you multiply your percent amount with your initial value. Same we will be doing over here. First, you please pay attention while calculating mass 2. Now look, this is your initial mass m1. From that you need to calculate m2. So how will you obtain it? m2 में से इतना अमाउंट माइनस कर दो, सॉरी m1 में से इतना अमाउंट, m1 में से इतना अमाउंट माइनस कर दो, you will get m2. So m1 में से कितना अमाउंट माइनस करना है? m1 में से इतना अमाउंट, and that amount is 48.8%. and how you calculate percent? You multiply that percent amount with your initial value. And what is that initial value? m1. Okay, so now you can calculate it. m1 is common, so 1 minus 48.8%. Instead of percent, I'll write 100 in the denominator. So m1, 100 1 is 100. 100 minus 48.8 upon 100. 100 minus 48.8.0, 48.8. So this becomes 10, 9, 9. 10 minus 8 is 2, 9 minus 8 is 1, 9 minus 4 is 5. So now m1 is 512 upon 100, which can be written as, m2 can be written as 0.512 into m1. You have the mass with you now. Next, with what frequency will the remaining balloon revolve? The balloon with mass m2, what will be the frequency of it? Let me call n2. Let the radius of my initial balloon be r1 and the radius of my new balloon be r2. Now, let me also talk about their density. Now, this is the original balloon. The balloon gets shrinks. The balloon shrinks, but the density with which the density of the material with which the balloon is made, that density doesn't decreases. When will the density of the balloon will decrease? When the balloon is stoned. Some part, when the balloon is stoned, when some part from the balloon, surface of the balloon is removed. Here, nothing from the surface of the balloon is removed. Only the mass of the balloon changes because the water has leaked. When you talk about balloon, just the size of the balloon changes, that is the mass of the balloon changes, but not the particles of the balloon changes. The density of the particle of the balloon remains the same, though it is means though it is filled with water or it gets shrink. density of the particles of the balloon remain same. So both the balloons have density rho. Okay, now for this I'll be using formula I1 omega 1 is equal to I2 omega 2. Now I1 is the moment of inertia of the first balloon with mass m1. I2 is the moment of inertia of the second balloon with mass m2. Both the balloons are spherical in shape. So for them they are revolving. So we'll consider moment of inertia at the center. So for center it is 2 upon 5 m r square. So for first sphere I'll write 2 upon 5 m1 r1 square omega 1. For second I1 2 upon 5 m2 r2 square omega 2. From here 2 upon 5 gets cancelled. Just wait. Now what is left? m1 r1 square omega 1 is equal to m2 r2 square omega 2. This is left. So okay, m1 r1 square omega 1 is 2 pi n1. m2 r2 square omega 2 is 2 pi n2. From here 2 pi and from here 2 pi gets cancelled. They have asked us to calculate n2. So m1 r1 square upon m2 r2 square and n1. We don't have radius. Nowhere in the question they have discussed about the radius of the sphere. So our next step will be to this formula. Density is equal to mass upon volume. So we are aware with mass. So mass is equal to density into volume. So mass 1 is equal to density 1. No, we will not be writing density 1 because density of both the balloons is common. Volume 1 upon m2 density upon volume 2. Why I have written m1 upon m2? Because see, if you notice we have m1 upon m2 over here. That is the reason I am taking ratios over here. So density 1, density 2 gets cancelled. What is the volume of the sphere? 4 upon 3 pi r cube. So radius of first sphere is r1. 4 upon 3 pi r cube. Radius of second sphere is r2. 4 upon 3 pi and pi gets cancelled. So now I have m1 upon m2 in terms of radius. So my next step will be m1 upon m2 is equal to r1 upon r2 the whole cube. Now I'll take this cube on this side, so that will become cube root. So m1 upon m2 cube root can be written in this format. Now I have r1 upon r2 in terms of mass. Now can you notice r1 upon r2 over here? Now we'll write this r1 upon r2 in terms of mass. So let's do that first. m1 upon m2 r1 upon r2 the whole square. R upon r2, I can write it like this because r1 is also square and r2 is also in square. n1 is equal to n2. Now m1 upon m2, let me write the square. n1 is equal to n2. Now what is r1 upon r2? r1 upon r2 is m1 upon m2 cube root. m1 upon m2 cube root. I'll multiply it with 2. m1 upon m2. Here we have nothing, means we have 1 into m1 upon m2. Here we cannot add, we will directly multiply. So 2 ones are 2 upon 3. n1 is equal to n2. Now see, here the base is sum and the base is getting multiplied, so the powers will get added. m1 upon m2. 1 plus 2 upon 3 will give us 5 upon 3. n1 is nothing but 1 is equal to n2. Now can I write it like this? Cube root of m1 upon m2 and raised to 5. Yes, of course, and I can write. Why I can write? Because of course 1 upon 3 is what? 1 upon 3 is nothing but cube root. I am talking in terms of power, okay? As we have considered it over here, 1 upon 3 See, when you take 3 on this side, that will become cube root. So instead of writing cube root, I am writing it as 1 upon 3. So I have removed this 1 upon 3 and left 5 outside, and instead of writing 1 upon 3, I am writing it in terms of cube root. Okay. Now we have seen that, let me write it over here, cube root of m1 upon m2 raised to 5 is equal to n2. We have calculated m2. On the first page we have done this calculation. M2, sorry, not this. That was a wrong, something mistake. M2 is 0.512 m1. 0.512 m1. So we will take that. M1, M2 is 0.512 m1, and here raised to 5 is equal to n2. So m1 m1 gets cancelled. Now cube root of 0.512, instead of that I'll write 1000. Why? Because there are 3 numbers after point. Upon 512, this will help me in making my calculation easier. Cube root of 1000 is 10. Cube root of 512 is 8. Raised to 5 is equal to n2. 8 ones are 8. 8 ones are 8. 2 remains. Because of point it becomes 20. 8 twos are 16. 16. 4 remains. 20 minus 16, 4 remains. Because of point that becomes 40. 8 5s are 40. So now it is 1.25 with power of into power of means power of with power of 5. सिंपल है. log लगा लो. एंटी log लगाएंगे तो log के पीछे आ जाएगा 5, and log of 125 is equal to n2 anti log here 5 into, you look for log of this digit. Before point you have 1, so 1 digit, so 1 minus 1 is 0. 0 point, you look for log of 12 का 5, and if you look for the log of 12 का 5, you will obtain the digit as, okay, so searching for my log bit. Log of 12 का 5, log of 12 का 5 is 0969. 0969. Now multiply this. 5 9s are 45, so you have 4, 5 6 are 30, 34, 5 9s are 45 with 3, 48, 5 0 0 plus 4, 5 0 0 is equal to nt log n2 48 का 4 का 5 देखो, so you'll get 3052. एक डिजिट के बाद पॉइंट डालने का into 10 raised to 0 is equal to n2. Now this is 3.052. Anything raised to 0 is equal to 1 rps. This will be the frequency of your second